Hello, welcome to First Lego League Refresher. We're going to look at some sensors today, but before we start, we have to look at the core values that are very important in First Lego League. And we're going to use the core values not just in our FLL classes, but also use them when we are meeting our friends, our family, whenever we are doing projects, when you're in school, when you're outside. Uh, One of these core values will come into uh, action. And so remember, these are not just in class, but in and outside of class. Really important. So we're going to start with that. So the gracious professionalism is the way we use these core values, and that's how it comes across uh, when you are working with your teammates, when you are responding and interacting with judges in the competition, as well as with other people that are around in during the competitions or in your classes and so on. So, what is gracious professionalism? This was a word coined by Woody Flowers. I encourage you to do a little bit of research on who Woody Flowers is. He has a long history tied to First Lego League and also just robotics competition in general. So look him up, do a little research. You will be amazed to find out more about him as well as and you'll understand why he coined the word gracious professionalism and how we incorporate that into the first Lego League. So, gracious professionalism is a way of doing things that encourages high quality work, emphasizes the value of others, and respects individuals and the community. So, it's not just about um, doing it for yourself, but it's also understanding that there are others involved and in giving that respect, providing the respect in various different forms, and also understanding that what you're doing actually has a big impact. So the six core values that we here in our first Lego League are discovery, innovation, impact, inclusion, teamwork, and just having fun. So we're going to look at this um, sort of in detail, but again, I'm just going to focus on one or two examples. So discovery, okay? So when I meet you next time, or maybe in the middle of a class, I might ask you about one of these core values and be prepared to not just understand it, be able to also put it in words and express it. Not just when you're asked a question about core values, but also when you are doing your other work. Uh, have that in mind that you're putting one of these core values into action, and so be conscious about that. Okay, so discovery. Discovery can be finding something new that will help you become a better student, better person. If you are an engineer, when you do self-discovery, you become a better engineer. So it really helps you to become a better self of yourself. So self-discovery or discovery is one of the core values. And then we have the innovation. So innovation, we've heard this word many times in our first Lego League, but also outside. We say that there's an innovative way to do something. There's innovation that's happening all around us, innovation in technology, innovation in science, innovation in engineering, innovation in medical sciences. So, what is innovation? Innovation is trying new things. It's also building new things with existing things, solving problems, trying to find a solution, right? That kind of leads into the impact. That's our third core value. Impact is something that you do that affects many people or the community, right? It changes something. Pacemakers are one of the examples of how much of an impact it had on patients with heart disease. And so, even though it was just one device, but it's been used by billions of people all around the world. So, solving one problem helps millions of people. So, that's what impact is. And you can have impact in your own team, in your own classroom. And so, think about what kind of impact you can have to with all your other teammates. Then we have inclusion, which, we've heard about this a lot, especially you've heard about the words diversity, equity, and inclusion. Some people call it equality, equity, and there's so many different words. But what it really boils down to is accepting each other's differences, right? And embracing the differences. So accepting each other the way they are and embracing the differences. When I say embracing the differences, don't see differences as something negative. That doesn't mean that because they're different doesn't mean they can't do the same thing, or because they're different doesn't mean that they lack something. Look at it positive way that they actually can add value for what you don't know or what you are not, right? They are, and so they can actually help you fill those gaps. And so look at differences as an opportunity to form a solution together, understand different backgrounds, understand different cultures, but also different mindset, right? That's also part of being inclusive. So everybody has different mindset. I can talk about several minutes about mindsets, growth mindset. There's positive mindset. I mean, there's so many different types of mindset. So understand this, that people are different, they think differently. Some people think logically, some people think reasonably, and there are so many ways people can think about a solution for a problem. And so understanding how they arrive at the problem, um, solving that problem, makes a big impact on you and your team. So keep that in mind. Teamwork, again, discovery, innovation, impact is not going to lead you to any fruit in your work if you're not doing it together. Teamwork is important. Yes, I know how to code, I know how to build a robot, and I also know how to write my missions. But at the end of the day, if you're not working together, that has no value, especially in FLL. Why? Because most of these missions, when you run them on the mat, you have to be able to talk to your teammates. You have to be able to work together. That is the biggest piece there. Without teamwork, there is no scoring goals, there's no scoring points. And so you can actually lose points because you're not interacting with your teammates. So work together, and same thing, use all of those other core values to help you interact more with your teammates. And then at the end of the day, we all want to have fun, right? So have fun. Fun is another big example. Enjoy the process, right? So when you are doing something, you're doing some engineering, you're doing research, um, don't do it because you have to do it. Understand the process and really understand that every process is really fun if you think about it. If you're looking at trying to research about a battery or battery management system or charging, these are all fun topics. And so find what makes you happy. Find questions, ask questions, try to do more research on why they exist or what can be done differently. Make it more fun for yourself, also for your teammates, right? So make sure you always keep that in mind. This is not a competition where you are all stressed, and I'm not going to be forcing anybody in my team to be stressed, because that's the last thing I want. Yes, we want to be competitive, but the that comes really to the bottom of my list. And most people will be surprised. They're like, "Oh, you're going training for a competition." Yes, we are training for a competition, but the competition is not happening on the floor, on those mats. The competition is actually happening really healthily. It's really healthy competition that's happening um, in the future, and we don't know when that is. We are getting prepared for that, and it's going to be healthy. It's going to be where we're not going to be stressed. We're going to have fun, and we're going to respect each other. And that's the type of competition that we are learning, right? So important thing to note is make mistakes, fail several times, and have fun. Again, these are the six core values: discovery, innovation, impact, inclusion, teamwork, and fun. So with that, I'm going to start the sensor refresher training. All right, so this is a spike prime kit that we use. So if you've already been with FLL, you already know that it comes with different sensors, different inputs and outputs. Outputs in this case are motors that will turn. Inputs are could be a distance sensor, which is also a ultrasonic sensor. It could also be a light sensor or color sensor, and there is a pressure sensor or a force sensor. So these are different kind of sensors. The hub, which is right in the middle here, is also a sensor. It has a gyro sensor. Again, I'm not going to go too much detail description of what these sensors are, but know that there are some outputs and there are some inputs, and then there is this hub, which is the brain of your robot that you're going to design or you build. And so that's what constitutes this kit, and then has other parts so you can build the structure and all of that good stuff. So I'm going to go to the next slide, look at the hub a little bit closer. So when you look at the hub, you realize it has several different ports. Okay, so there is port A, B, C, D, E. That's total 6 ports for input and output. But there's also a charging port, which one of my students pointed out is also a port where you can talk to the hub and download programs and so on. So that's the 7th port. And then there's another wireless port in the sense there is a wireless connectivity. So it has Bluetooth. So this represents the Bluetooth. And of course, it has these buttons to turn on, turn off, and also the left and right arrows to change programs. What does that mean? It has a memory. Of course, it's a computer, and it can store your programs. It can store, I believe, up to 10 plus programs. And you can go uh, left, right, 1, 2, 3, 4, 5, and you can activate that program by pressing the big button in the middle. And so that's your prime hub. This is the main brain, the the brain of your robot. Sensors, that's what we are here to talk about. The spike sensors are these are the main 4 sensors, right? There's force sensor, which could be a piezoelectric. Again, I'm not going to define all these things, but they can also be made of in thin metal wire that when you press gets stretched. When you stretch something, the thickness decreases, and for a conductor like a wire, metal wire, when a thickness decreases, the resistance increases, right? When there is very little path for current to flow, the resistance increases, thereby the signal that's coming out varies. And so that's how you measure how much force has been put. The force sensor is goes from 0 to 10 Newton. And so it's very useful when you are trying to figure out what kind of force is being applied. Similarly, we have color sensor that can detect certain colors. And so that's a light sensor slash color sensor. Then we have the distance sensor, which is an ultrasonic, which means there are 2 sensors. If you look at, one is a transmitter and one is a receiver. And the way the ultrasonic sensors work is it sends out a signal, it hits the object which is in front of it, and then it gets reflected back. The time it takes to hit and come back is then converted into the distance, and so that's how the robot knows how far or close it is to an object. Then the gyro sensor. So the gyro sensor has um, vertical velocity, horizontal velocity, which is yaw, roll, pitch. Not going into detail, but it tells you whether the robot is perfectly horizontal or it's at an angle. And you can use all of that different positions to maneuver your robot to do actions, to do various things on the robot game. And so keep that in mind. You have these different sensors and these different properties of the sensor that you can utilize to run your robot game. So what is a sensor? A sensor simply is something, which you see this blue box here, is something that converts the physical properties of a matter. Okay, some of the things that are physical are the lengths, right? Distances, lengths are physical, something you can measure. Color, right? Something you can see. that's color. Apple is red. Uh, Again, there can be a green apple, but it's something physical. You can see density, how dense some objects are or some liquids are. Again, that's a physical property. And then elasticity, pressure, volume. There's so many other properties. So the sensor converts these physical properties into an electrical signal. That's what a sensor is, okay? In a simple form, it converts a physical property of a matter into an electrical signal. There on the right side, you see this is an electrical signal, and the x-axis shows the time, and then the y-axis shows the current or voltage. So like in the examples of the force sensor, as you press down on the force switch, or what do you want to call it, the one that moves the lever, it pushes or extends or stretches the wire, thereby increasing the resistance, which means it decreases the current flow in that sensor. And then you can measure that, then you can convert that into the number of newtons of force that you're putting on that sensor. Let's take a look at the color sensor real quick. Now, before we go into the color sensor, let's try to understand how we as humans see objects and are able to identify different colors, okay? So for example, I have this is an example, I have this purple, or you want to call it pink, purple piece of plastic that's part of your Lego. And the reason why I'm able to see this color is because there is a combination of colors that make up this color is being reflected back into my eyes. So if you look at this apple in the slide, you're able to see this red apple because all of the colors that are coming in, that's white light, hitting the apple, and the apple is actually absorbing the green and blue, but reflecting the red. And as a result, you're able to see the red color. Similarly, this gives you an example of all the different colors you're able to see. So if you look at the rectangle, that's the color of the object, and it tells you what light has been hitting it and what has been reflected off of it. So for example, if all of the light that hits it gets reflected, then you see a white surface. Similarly, the red surface, we saw that with the case of an apple. Then you have the yellow, where red and green are emitted out. When red and green mix, you get yellow. Same thing with this red, green, and blue. Green gets reflected out. Similarly, you can see if nothing gets reflected out, everything gets absorbed, or most of it gets absorbed, you cannot see gray or black. And that's what that is represented. And so we move on to different colors. Now you get the idea what really happens when you are actually looking at an object. It's emitting something and absorbing some other colors. And so that's why you're able to see. Well, there are many different types of sensors, and you need to be aware of these, even though we only use a few sensors on our FLL spike prime. Uh, in the world, there are plenty of sensors. You heard of gas sensor, rain sensor, there's humidity sensor, there are infrared sensors. The ones that are used in your remote to control your TV there is a transmitter and a receiver, mostly transmitter, and the receiver is not on the remote, it's on the TV. So when you're trying to switch a channel, change a channel, control your volume, each of those buttons have a function, and they emit a certain frequency and tells the TV to do that function. All right. So now that we know that there are so many different sensors, and they may have different technologies. So the force sensor, for example, which is made of um, could be made of a metal wire, or it also could be made of a silicon piece of chip that is a piezoelectric. There are so many ways to actually have a force sensor. You can use diaphragm, you can use elastic, you can do various things with a force sensor and build one using various materials. So we are going to look at the force sensor. This is by a company that makes these force sensor called Futech, and these are actually used in vehicles. And if you look at here, I'm going to play this really quickly for you. It doesn't play here, but there you go. So if you notice on the screen here, it actually does something. It actually, the two arrows, when are the compression points, when they compress, the metal which is right in the middle, that's the metal, it's the wire, it gets stretched. When it gets stretched, the thickness of that wire really reduces. Okay, and so when the current is passing through it, it hits across higher resistance. As a result, there is a variation in the current. I know I'm talking too many words of electrical language, but if this is another example. So if you notice here, you can see on the left hand side, so if this is the wire expanding, you can see that it's changing the resistance. R1, R2, R3 are different resistance. And so it changes the resistance. As a result, different signals come out of it. And if you measure that is when you can get what it is. You usually calibrate it. And when you say calibrated, when you say if it's stretched at this and if it's about 350 ohms, that's the measurement for resistance, then it means that it is, let's say, 5 newtons, which is again a measurement of how much force. So once you calibrate it, so now you know that zero resistance means this much Newton, 350 resistance means 5 newtons, and so then you can easily measure how much force you're putting on that sensor. So this is an activity which you can do without the hub. If you have the hub, great. But if you don't have the hub and the sensors, that's perfectly fine. What you want to do for this activity, which will take you about 30 to 40 minutes, is to download the Spike Prime app from the App Store or the Play Store or your Microsoft Store or whatever device you're using. It has a marketplace. Go and search for Spike Prime and download the app, install it. Once installed, you can create a new program. And I want you to use either the force sensor or the distance sensor, preferably the force sensor. Now, try to work on this, do a little bit of research on where you can find those modules. I prefer the block editor versus the Python because you can actually uh, drag and drop those different controls and different modules or different, those different diagrams that you can pull from the sidebar. So for sensors, you'll find a force sensor which has a certain symbol. Again, I'm not going to look at it this session. We'll look at it when we meet the next class. But I want you to figure out a way to use the force sensor to drive the speed of a motor. So remember, you're using two ports, one for input, which is going to be your sensor, and the other one is going to be output for a motor. We're not building any robots. We're just using a hub, connecting those two cables, and just trying to see if we can cause and produce an effect. So we're pressing the sensor or covering it, whatever sensor you're using, and seeing if the motor can turn. And in this case, I want you to program a motor to run at various speeds depending upon the different levels of the sensor that you're either pressed, different levels of distance, different heights or different lengths of the distance that the object is at. Um, so once you figure out how to do that, that's gonna get you ready further into using these sensors. And then we can look at more advanced programs for doing some color sensors, following a line, and so on. So that's the activity. And if you're done with the activity, then I would like you to answer these questions before you run the program. Is what input modules will you use? What output modules will you use? Be ready to answer these questions in the next class. And then after that, I want you to build your program, of course, and I want you to do this quiz. Okay. Now, before you do this quiz, if you can get a phone and scan that barcode, it's going to take you to a web page. You can ignore you can ignore this, this website. Don't worry about this website, but just use that barcode. It'll take you a web page. in which there are 3 or 4 research material topics. I want you to research on all the 3 topics and then answer the quiz that's in the same page. Make sure you put your name, and I will check all the results of that quiz, and we'll discuss next week. And there is special prize for whoever does a pretty good job, and I'll make that decision on answering all of those quizzes. And there are some fields in them that you actually have to type your answer. So I'm looking forward to that. Again, if you have any questions, ask an adult. But if you have questions that you want to ask me, hold on to it, write it down somewhere, and then bring it to the next class. And next class is going to be next week. It's going to be virtual, or it could be in person, but check out the schedule. Until then, I tell you all the best, and let's learn together. Thanks.